In a previous video, I was showing you how to find the derivative at a certain point using the long way, using the long method here. And I think that the graph I had drawn looked something like this. And I know I used f of x equals x squared, x squared plus 1. So that's the equation of this line right here. It's probably pretty close to what it would look like. So we're going to go over something called the power rule, and it looks like this. The derivative of a number to the power. Okay, so this here would represent x, of course, and this number here is going to represent n. Equals n times x to the power of, raised to the power of n minus 1. And if you do that out, it's pretty simple here. So we've got x squared. Let's just do it out down here, I guess. So we've got 2 is n. Okay? I hope you see that. This represents n here, and this is the x. So we've got 2 times x raised to the 2 minus 1 power. And when you simplify, that comes out to just 2x, because it's 2x to the first power, which is 2x. And now you can use this right here. This is the derivative, and we write it like this. That little apostrophe or whatever you want to call it. F sub prime equals 2x. And we can use this equation right here, the 2x, to find the slope at any point on this line, any given point on this line. So this point here, this is 1, 1, 2, right? 1, comma 2. The derivative of 1 equals 2 times 1, which equals 2. Alright, so anyways, let's see if we can fit another example on this page. We're just going to do it up here at the top. Using the same graph and the same line here, let's say that we have, bear with me here, because the graph is not to scale, and I don't want to give you the wrong idea, but let's say that this point, we got 2. Really quick, it's going to be 2 to the 2, it's 4 plus 1, it's 5. So it's going to be 2 and 5. 5 is going to be somewhere up here. But don't pay attention to that. It's a point that's somewhere up here. We want to find the slope of this at this point. And how do we find that? Well, we use the same exact formula, which is useful. You can use it for any point on this line. So if we plug that in, we have what was 2 equals 2 times 2, which equals 4. So the slope at this point right here, at this exact point, at 2 comma 5, the slope is going to equal 4. So the rise over the run is going to be 4, or it's going to be the rise is going to be 4, and the run is going to be 1. It looks something like that. This is a really crude drawing. Sorry for that, but you know the point is that without the graph here, finding the derivative is simple using the power rule. So let's do several more examples. I'm going to clear this screen here. Okay, nice clear screen here. And just to recap power rule, the derivative of a number of x to the power of a number equals that number times x to the n minus 1 power. Let's go through a couple examples here. I think that going through these will give you a pretty good idea of what we're doing here. So x to the third, using the formula, if you plug it in, I'll give you a second to guess it, and you can just do it this fast. The 3 goes in front, 3x, and then it's going to be the n minus 1, so it's going to be 3 minus 1, which is 2. 3x to the second. Now this one down here is a little different. In the case of, because this one has a coefficient, in the case of this, the simplest way to do it is just multiply the power by the coefficient. So it'd be 12x to the third, following the regular rules. You're taking the coefficient out and then you're multiplying it by the result that you get, which would have been 3 times, you got the 4 there, x to the third, which equals 12x to the third. You can see how that works. Same thing up here, taking the 5 out, times, you got the 2, move the 2 to the front, according to this formula here, 2x, and it's the 1, so we need to put the 1, which equals 10x. And these are the actual derivatives. It's this easy to find it. Same thing with this one. Just multiply 40x to the third. Anyways, that's your basic rundown on how to use the power rule to find the derivative. You can see how this is much easier than the limit method. 1,000 times more efficient